Welcome back to the workshop. We want to take a look at another example in rooted trees. For this example, we're going to find all of the partitions of the set A, B, C, D. While this example is currently for rooted trees, of course, anyone looking into finding partitions would be interested in seeing this video, because you don't have to have an in-depth understanding of graph theory or rooted trees themselves to be able to utilize this particular example. So again, let's find the partitions of A, B, C, D. We'll find our partitions by constructing them, by first finding the partitions of one element, then adding another element to that, find all of those partitions, and then add a third element, finding all of those partitions. So we're going to start off with just A. As a reminder, a partition is a way of separating or a collection of subsets such that the union of those subsets gives us back the entire set, and none of the sets have anything in common. So for example, A, B, and C, D is a partition of A, B, C, D because it's a collection of subsets. There are two of them. And when we union these two subsets together, we get back the original set, and these two subsets do not overlap. There are no elements in common. Excellent. So there's only one way to partition the set with one element. That is that. That's it, right? It's just the entire thing. So if we add to that B, we could add B to this in two ways. We could either put B inside the set with A, or we could add B to the set outside the set. Okay, so when we're thinking of constructing a rooted tree, we're thinking of it as, how can I add B to the sets that I already have? I can either add B to that set inside the set, or I can add the set containing just B. All right, well, there's no other way that I could have added B, so now I consider, well, how can I add C? Well, I can add C inside this set or outside, inside this set, or outside all of those. So that is going to give us, let's see here, two options for this, where I have A, B, C adding inside the set, or I have A, B, and add C outside the set. And then again, there are three options for here: add inside, or outside. So I can have A, C, B, and B, or I could have A, B, C, or I could have A, B, and C. There we go. Now I only have one element left to add, and that is the element D. So there's two ways that I can add it to this set. There's three ways I could add it to this set, three ways for this set, three ways for this set, and four ways for this set. So I just need to list those. I'll list them underneath. So I can write this guy out as A, B, C, D. I can add D inside the set, or I can add D outside the set. So I get these two additional sets. Here I can add D to this set, or outside of the set. So that gives me A, B, D with C, A, B, CD, or A, B, C, and D. So that gives me this set, or that set. And then here I can add D to this set, or outside. So I get A, C, D, and B. Or I get A, C, and BD. Or I get A, C, B, and D. So that gives me this set, gives me this one, or that one. Running out of room here, so we'll have to make sure that we draw arrows well. You might find yourself writing on a piece of paper that's normal orientation, so you've got some more vertical room here, or maybe going with the landscape orientation, really spreading things out would be convenient as well. All right, so let's see here. I'm going to write these guys down below here actually, so I can add D to this set, D to this set, or outside of. So A, D with BC. And I can add D with the second set, so A with B, C, and D. And then finally A with BC and B. So this set gives me these three, and then finally I get 4 from here. So I've got A, B, I'm sorry, not A, B, A, D, B, and C. I've got A, B, D, and C, A, B, C, D, and finally adding D on its own, A, B, C, and D. So this set gives me 4. All right, so I might encourage you to spread that out a little bit more. Of course, it would be ideal to have nice edges from one set to the next, like we have for these first few, but then once we get to these, they're kind of connected. So being able to write that out with a little bit more space, of course, would be nice. But this now gives us all of the ways that we can partition the set A, B, C, D by considering all of the terminal vertices. So terminal vertex, terminal vertex, terminal vertex, terminal vertex, terminal vertex. These are all the ways in which we can partition the set A, B, C, D, and it is all of the partitions, right? So that's what we're focusing on there. We have identified all ways of partitioning the set A, B, C, D. Excellent. All right, that's all for this example. I hope you guys found it to be a little bit insightful, and for those of you looking for partitions and not necessarily rooted trees, I hope it was also helpful for you guys. I'll see you guys later, again, here in the